Hello, everyone. Today we have a 8th grade elementary school problem. Um, this problem is a mixture of algebra and geometry concepts combined, and essentially, over on Reddit, someone is looking for help with this problem. So the question is, if you can choose, you have a can of cola, and if you can choose any diameter, which dimension for the can would use the least amount of aluminum to package 330 milliliters of cola? So what I like to do with these kind of problems is kind of break down everything, and um, I like to give three categories of information that we know, and well, two actually, and then have the question at the end. So in the problem, we're given that the volume of the can is 330 milliliters, and so this is something that's going to stay the same, um, and this is given to us by the problem. So there's a couple assumptions that you need to know, and that you're expected to know in order to solve this problem. First thing, this is the reason why geometry is involved, is you need to know the volume of a cylinder. I'm sorry, can I edit this? So this is incorrect. The volume of a cylinder is not pi r squared. It's pi r squared times the height. So I'll just put the height, which is h, times pi r squared. And then we also need to know the surface area of the cylinder, which is 2 pi r squared plus 2 pi rh. Again, as a sort of connotation, the radius, I label that r, and the height is h, as you can see here as in a cylinder. The next bit of information that you need to know is that 1 milliliter, which is a volume, is equal to 1 centimeter cubed. So this is just a conversion. And again, these three things you can look, if you don't know it, the good thing now is you have Google. You can search up the volume of a cylinder, you can search up surface area of a cylinder, and then you can also look up conversions. So the reason we use centimeters cubed is because we know that a unit of length is a centimeter. So volume is in the cubic dimension, or centimeters cubed, or centimeters to the third power. And so the last assumption you need to know is that the volume of the can stays the same. However, you can change the dimensions of the can. So you can change radius and you can change height. So in here, I kind of drew two examples. They're not exactly to scale, but you can see here on the first one, you have a higher height and a smaller radius compared to the second figure, where the radius is bigger, but the height has to be reduced. And the reason for this is it's not exactly drawn to scale, but let's just assume both of these cans hold the same amount of volume. So basically what this problem is doing is adjusting the height and the radius configurations so that you're having the least amount of aluminum. So imagine these two shapes, hollow shapes, have aluminum all around it. So we want to make sure the problem is asking to find the lowest amount of aluminum, which is essentially the surface area to hold 330 milliliters of cola. Okay, so now that we have the given, the assumptions, and the questions out of the way, we can kind of work through this problem together. So the first thing I'd like to look at is the surface area. So we know this is the formula for the surface area of the cylinder. Now when we have that, take out my pencil here. So that's given. And then when we look at the volume of the cylinder, it's pi, or height times pi r squared. We know that the volume is given as 330 milliliters, and again we have the conversion. 1 milliliter is 1 centimeter cubed. So we have 330 milliliters equals 330 centimeters cubed. So that's a 1-to-1 conversion. So that's easy to convert. So then once we have that, I can substitute the volume in this equation. We have 330 centimeters cubed equals h times pi r squared. H times pi r squared. What we can do with this is rearrange this equation to find h, and you just do a little bit of algebra. So here what I would do is I would divide by pi r squared on both sides. Those cancel out. Right, straight line. And divide over here. So now what we have is h equals 330 centimeters cubed over pi r squared. So let's write that down somewhere. Keep it a little neat. H equals 330 divided by pi times r squared. I'll just see if I can erase this. So we have some space to do some other things. All right, so that's there. So we'll leave that for now. The next thing we want to do is see if we can plug in this equation into the surface area equation. So we have 2 pi r squared plus 2 pi rh. So basically all I'm going to do is, for this last term here, I'm going to replace it with this expression. So what that looks like is, and I'm going to call the surface area SA, just so I could save some space. I'm going to say SA equals 2 pi r squared plus 2 pi r. And so this is where the h would go, but since we figured out earlier, it's 330 divided by pi r squared. So I'm just going to write that here. 330. Oh, that looks like a 6. 330 divided by pi r squared. This is our new equation for surface area. Looks a little sloppy, but hopefully you can follow along. Again, it's this equation right here, the surface area of a cylinder. So basically, we're going to do some algebra. We're going to try to reduce this equation into something a little bit easier to comprehend. So the first thing I would do here is I see that with the two additional terms, there's a 2 that's in common. So I'm just going to factor out the 2. Simplify it here. So we factor out the 2. And then what we're left with is pi r squared plus pi r divided by 330. I'm sorry, times 330 divided by pi r squared. And I need another parentheses here. Okay, now that I see this, I think this term right here can be simplified even further. And so one of the things I see is we have pi r, which would go into the numerator, and we have pi r squared, which would be at the denominator if you were to solve this out. Basically what I can do here is those cancel out, then what you're left with is 2 times pi r squared plus 330 divided by r. So hopefully you can follow that math. That little step right there. If we were to multiply pi r times 330 and divided by pi r squared, we would have 330 over r. So that's this term right here. And this term we're leaving alone. I think that will simplify it enough for our purposes. So again, just to recap, we have a can, which can be represented by a cylinder. We have the equations for volume and surface area. We're given volume, so then we can write an equation for height. We rearranged it. We plugged in the volume right here, so that's 330. And so we have the formula for height. Given anything that you pick for r, because that's what we really want to know, the question asks, the r dimension. And so basically anytime you adjust the r, your h is going to have to adjust in order to maintain 330 milliliters. We converted the 330 milliliters to centimeters cubed. So that's our unit. And then finally, we needed to find the lowest amount of surface area to hold 330 milliliters. And so that's what this equation is right here. This is the equation for the surface area given any value of r. So if you can see here, the only thing you're changing is r. This will give you the surface area. So basically, if you were to test if you were to plug in a whole bunch of values of r, you would find which value of r would give you the lowest amount of surface area. Or another way to do it is, since this is an 8th grade question, I don't believe that you know calculus. But if anyone else is watching and they know calculus, you would take the derivative of this equation, set it equal to 0, and then you would solve for the r, and you can get your minimum. But since more than likely we haven't taken calculus, we're not going to explore that solution. So this is one step before the final step. So now that we have this equation, you're going to have to graph it into your calculator, or there's actually a online graphing calculator, Desmos.com. So you can type your equation here. So that's basically, this is it right here. You can replace the x for r, just to stay consistent. Or I'm sorry, it's my first time using this calculator, so I'll just leave it as it is. So basically the x's would represent the r that we kind of determined in this formula here. So just replace your r with x. That'll give you your radius. And if you were to look at the graph, you would see it extends to negative infinity to infinity. But here on the x-axis, we have the lowest point, which is here. The lowest point is 200, or I'm sorry, the lowest point, depending on how we look at that, the value of x is 3.745. And that'll give you 264.3. So let me write that, 264.35 equals 2 times pi. And for x, we have 3.745. 3.745 squared plus 30. So just to kind of double check this, you can enter that in your calculator to make sure that this equals 264.35. And again, the easiest way to do it is to use a graphing calculator, or if you're online, there's this website you can use. You can enter your formula here and it'll graph it for you. All right, so hopefully that helped. And again, I usually like to go through everything you're given and everything you kind of know. So this usually helps me out. Just write down things that you know. Then you could kind of figure out how to go through from there. All right, thanks for watching, and I'll see you next time.